In today's project, we built this portable battery box. Alright, so let's get started building this pack. So this is a 32650 cell. They are a battery hookup. They're the 6000 milliamp pack. It is going to be in a 4P and a 4S. So 4 in parallel and then 4 in series. This is a lithium iron phosphate, so they are nominal 3.2 volts, so this makes a really good replacement for a 12 volt pack. And we're just going to use these basically to make a small portable battery pack using one of these Harbor Freight cases. So I'll get that in there. For now, I got the K-weld set up, and we will start spot welding. I got some of this 1P strip, so this will be really handy to connect these cells, make it a lot easier. So, alright, let's start welding some stuff on here. Thinking I'm probably going to set the K-weld to 50 joules to start out with. We'll see how that works. Maybe we'll do a test one real quick just to see how it's ripping. Cut a small chunk off. And we'll just test on one of these random negatives real quick. I'm sure you guys can see. Might do just a tad bit more, but I also didn't have it on the between the dividers. I don't know if you guys can see that. You're supposed to weld between those areas, but since I didn't have one on that particular sheet that I tested, we'll set it to 55. This is 2mm thick pure nickel, so looks like we can cut this one right at the end right there. Get it as lined up as best as I can. Just like that. So now the other side will be on both, and this will be our main positive and our main negative. And for that, just got some single and this isn't going to be like a high output pack or anything. It can deliver up to 60 amps in this configuration, but for what we're using it for, we'll be nowhere near that. So cut that a little shorter. Looks good. A little crooked on that one, but it'll be okay. All right, that all welded up. This K-weld, I really do like it. It does some fantastic welds. All right, now these two and these two will now be connected, and that will give us our 4S configuration. And like I was talking about, these strips, if you guys never used these before, you see that little hole in it? So you spot weld between it, and what happens with that is it's easier for the resistance to go straight through the nickel, especially when it's thick, and then you don't get a good weld. But if you have that hole in the middle, it actually makes it go down and come back up, so you get a better weld. And if you do have a K-weld, don't try to weld at my settings. I am using a DIY battery that I built for this, so your settings will vary depending on your battery. Mine is putting about 1400 amps out at 4S. Okay. Battery is starting to get pretty warm, but I think we'll be able to finish this up without letting it cool down. All right. So there we go. All welded up. If we test this voltage. And another thing to note, I did check all these cells. They are brand new, but before I bought them, they were all within, a couple volts of each other. They're not hugely different, so we should now have our 13 volts. You guys can't see. Here you go. You see? There you go. Yep, so 13.2 volts. So I do have a BMS coming from this. I'm gonna run a Daly Smart BMS. They're the newer guys, with a screen attachment, and that will let us see amp draw, so it has a built-in shunt. It also obviously monitors each cell, so we'll be able to see the voltage of each cell group right from the BMS screen, so we won't have to use something like the RC cell monitors. You can use these on a balance lead and see that information as well. But since these new smart BMSs have all that built in, I think it's going to make a really clean build. So we're going to run with one of those as soon as it gets here. Hopefully it'll be here sometime this week, and then we'll solder on our BMS wires, and I'll show you guys how to do that. But for now, this part is done. Probably actually going to throw it on the charger, the balance charger, and just let it charge for now, and then go from there. So temporarily, just so we don't have any accidents, we're gonna put some Captain tape on this. Try to stay out of your guys' way. But yeah, you definitely do not want to short these out. Lithium iron phosphate is much safer than your typical lithium chemistry like an 18650 or a LiPo cell. They don't really explode like they do, but nonetheless, I still don't want them shorting out. And the nice thing about lithium iron phosphate as well is they make a really good 12-volt replacement. So for you guys that watch the cargo trailer conversions and stuff, essentially what I'm doing is testing these cells to see how good they're going to be. And if they're good, then I'm going to use them in the camper in a 24-volt setup, so an 8S and probably like a 320p. So, or excuse me, it'd be like 40p, but 320 cells. So should end up with a 24-volt, 240 amp hour pack. And then each one of these cells are capable of doing a 3C discharge burst. So that means there's 6,000 milliamps times 3. And that would be your 3C charge rate, or discharge really. It's not really charge rate, it's discharge. All right. So now I just need to get some leads on here so I can charge them. Let me grab some wire real quick. I think I'm just going to use some 10 for this nice silicone wire. Again, this is going to be a very low draw pack. I'm not going to be trying to draw the 60 amps out of this pack. It's mainly going to be charging laptops and cell phones and that kind of stuff. So I'm not running an inverter off this. We do not need to go crazy with like any kind of 8 gauge or double it up or anything for this small of a pack. It just wouldn't be efficient with this many cells. This is just mainly experiment to test these cells out. So I figured if I was going to test them, I might as well make some kind of useful portable pack out of them. So we'll just chunk a couple pieces of wire. Personally, when I build battery packs, I like to solder the connection end on first before I put it on the battery if I have the option, so you don't run into a possibility of a short. So let's move this guy out of our way for now. We're just going to run a XT60. Go ahead and tint up the end of the connector first. On the wire. A little closer. I'm just watching that solder for it to suck inside the wire. There we go. On these, flat side is positive. If you're not familiar with these, there's a typical like RC style plug. So flip that around. This part can get interesting. Kind of hard to film this and hold everything at the same time. There you go. Good looking solder joint. And this is exactly why I said I like to do these first, because you can see how close these get. I will need a little bit more encouragement to stay in its spot. Now, if you are doing this on a battery, don't forget your heat shrink or your end. Never fails. Trying to put this on without burning myself. It's still pretty hot. Just the pliers. There we go. Alright. Strip just a tiny bit more off these ends. Spin the wire around to make sure we got that solder sucking up in there on all sides. Currently have my iron set to 900. This is some pretty thick wire. So you want to make sure your solder is going into your wire too, not just sitting on top of it. All right. So now, as I mentioned, main positive, main negative. This part you're going to want to be really fast with. You could technically spot weld the tab off of this and then use that as the solder on. But I'm just going to solder right on top of the battery. But you got to be careful with this, and you got to have a good iron, because if you're not quick enough, you can actually damage your cells. But this iron's pretty hot. You see it tin that up really quickly. So we weren't on there very long at all. And I like to melt a little solder on there just to spread the flux out like this. And then feed it on there, move it around. There we go. I'm gonna alternate. I go back over here now, start that melt. Solder is always hottest when solder is flowing, so add a little bit will help it suck down on there as quick as possible. Hold it with something. There we go. So now, these battery testers, plug it in. You can see at the very top, we got our pack voltage. Now obviously I don't have a balance lead hooked up to this right now, so we won't see anything but that. I have some of that stuff coming tomorrow, so I think for now this part is done, and then when I get the balance leads, I will do the balance points, and then we will be good to go. So all right, another thing I'm actually gonna do real quick before I get those leads is I cut some of these little tabs out real fast. I'm gonna solder them on in the middle, and then we'll spot let them down, and that'll give us a spot to solder our balance lead, so we can minimize the soldering on our batteries as much as possible. I did it on those because like I said, it's going to be a main bus bar kind of thing, and the top I think is only 0.15 millimeter nickel versus the 2, so foot pedal's falling over. All right. And should mention that since this is a nickel to nickel, I did turn the spot welder down quite a bit on these. Am I at 24 joules on my setup? Alright, there we go. So now we'll just put some solder on those. Try not to melt my 3D printed holders in the bottom. There we go. Now, if you guys are not familiar with building these packs, these tabs will make more sense to you later on when I get the battery management system in, or BMS. It essentially monitors each cell group, so we need to have a way to attach wires to each one of these cells. I just prefer not to solder on them as much as I can. Alright, there we go. So I think next we will, said I had some alligator clips I can charge this with my RC charger to get that all balanced out. We're going to use this little case from Harbor Freight. So this thing is quite small. You can see I 3D printed out this front panel. I have two XT60s. Push button switch to turn on and off the USB 3.0 quick charge ports, and then we just have a regular cigarette lighter socket. And at the very top I have a balance port. Do I have a cable around here? Yeah, so one of these guys. So when I get my other leads in, essentially that goes through the top and pulls down and then goes into the battery, so you don't have to open the pack up every time you want to check the cell balance. You can just plug it right in the top. I'm not crazy about this 3.0 quick charger seal. It goes in there kind of hard, and it's unfortunate I didn't have any black ones in stock, but that's okay, that'll do. So this pack's mainly going to be for charging phones, laptops. You could plug a PD charger in here. You could easily do a 100-watt PD charger off of this pack, no problem. And like maybe if I wanted to charge some of my RCs out in the field, or plug in a solar panel. So I do have a little 50-watt, or I have up a 200-watt solar panel I can plug in this with a charge controller. That'll just be external to the box. So you can charge with a solar, you could charge with an RC charger. You could do a DC to DC converter if you wanted a constant current, constant voltage to charge this. So there's multiple ways, but these ports will just make it easy. Plug it right in, plug your balance lead in, there you go. Or your solar, or whatever you're using to charge it. So what we need to do, I guess I could wire this up real quick. Well, some of it. And then we need to cut a hole in the top of the box for that to go right there. If you guys are interested in this front panel, let me know. I can post the STL files or post it on Thingiverse, and you can print it off. So yeah, let's do that. I gotta think of what I need. So positive, negative. Okay, so that's for the LED. It's just gonna clip on there like that. What I'll probably do, some kind of bus bar off of this. These two are definitely gonna get a bus bar. Use a piece of thick copper for that, some 6-gauge copper, solid. It's grounding wire. Pull this off here so you guys can see a little better what I'm doing here. Just tin in the back of the XT60s. I would normally be using my fume extractor, but it's so loud you guys wouldn't be able to hear me over it. Alright, so let's show you what I'm going to do for this. So I got some of this just solid copper. You can get that at Home Depot or hardware stores or whatever. And then that has a coating on the outside. Keep it from corroding. So we need to get that off of there. So what I like to do is just try to straighten it out first. Measure my piece out. Pair of side cutters and just cut a little extra so you can solder your main leads onto it. Oh, my big hand's in the way, you can't see. There we go. Now I just have this little 12-volt drill that I keep on my electronics bench. Another piece of sandpaper. You can see how much shinier that is now. So, see the bottom half, not shiny. And if you try to solder that with that on there, you'll have a miserable time. So, just takes a second. Thought I lost it. You guys see that anywhere? Gone forever. Okay, well, whatever. I'll make another. I'm trying to do this box all in one build. Hopefully this video doesn't get too long, but it is a smaller project. So I really would like to just get it all done quick in one video, guys, so you don't have to wait for a part 2 of this thing. Let me know if you guys mind the longer videos or not. Alright, so once I get it kind of stuck on one side, I'll then heat up the other side, and those these twist in here, so it's pretty easy just to pull them in like that, a pair of pliers, and then feed it some solder. You be careful to get this too hot and you'll melt the other side off, and then you'll have a fun time trying to get both sides to stick. So just keep in mind how much heat you're putting into that. So I also made like an XT60 power strip, and that's made the exact same way, just in a nice little 3D printed case. I use these things all the time. I don't think I'm going to be able to do all these without being in your way, but I'll do my best. I don't have a ton of room to work with this. So we're gonna tin that end up first. There we go. So that one was being a little tricky, but we got it. You can see how it's hot enough where it wants to pull both ends. I'm just gonna make sure they're both on there. Alright, so now we'll be able to just solder a piece of 10 gauge to that later on. And connect them both all at once. Oh, I forgot to glue these. Yeah, so I never glued them. Oops. I just used some basic super glue, and this is a PETG print. Once you put this on there, I've never had one come back out. They're pretty much there forever. So make sure you want it there. Try to hold that down real quick. It's still pretty warm. All right, here we go. So let's move this cable out of the way. also kind of playing with the idea of doing a little bit more of that same thought, because all the grounds need to go together. So we could run it right down to our front there. That would be kind of slick. I think let's try that. Let's see how we do. This is just a piece of 14 gauge Romex. Actually, I might even leave that coating on there. Yeah, if I can. I don't know if I'll be able to get away with that. Let's see. If I have... Never tried to split Romex like that. Just need to strip a little bit more off of it. That'd be a lot of work to keep that on there for no real reason, but it'll look nice. Something like that. Now, even though this isn't, you know, just bare and it is insulated technically, it's still got that coating on there. So kind of screwed myself there. All right, I give up on that. Let's just I like that, but I need it to be more that way, and then we kind of run into that. Yeah, we're just gonna end up hitting that plug. All right, that's fine. Whatever. We'll just use regular wire. It's worth a thought anyway. So this is what they gave me with it. This does have the built-in glass fuses, but I don't think I'm going to use those. I'll probably put a fuse later down in the line, but technically you don't even really need to because the BMS does have short circuit protection, so you really don't even need one. I generally solder these on, but these are actually some decent wires, so we'll go ahead and use theirs. That. All right, so my thought was we could use this as a bus bar, and we could basically run everything off here, and then we only have one wire going to our battery, which would be nice. So let's go ahead and snip off some extra here. And I need to do a test with the switch to see which way it lights up here. So ground, these are going to be the switch leads. So one of these ways should turn it on. Let's go ahead and just use our new pack real quick. We're going to be switching positive, so we're going to stick the negative down in here. And we'll stick this down in there. And if that's the right side. Yep, see when I push the button it turns on now? Okay, so those two wires need to live together. And I'm not going to switch to lighter port, just the USB. I don't know if I have any heat shrink in here that's big enough anymore. See if I can find some other stuff. Uh-oh. Oh. Found some green. Not really the color I want, but it'll work. these grounds need to put together. I'm gonna try to do a center splice on this. See how we fare. Alright, we're back. I had to swap out a GoPro battery. Pretty happy with that. So now we just need to run these two right down here via this pin. Just like that. I think we're golden. Now, when this is in a box, I'll probably try to, you know, zip tie some of it up. But I didn't want to cut the wires too short. Something like that. So, all right. This guy feels a little long. Take some off of him. Yeah, that'll do nice. Okay. Make sure back is positive. Load some more solder up on this back half. Turn up my iron again. Hang on a minute. Alright, there we go. See that? I know it's hard to see, but it's a plenty good enough of a joint. All right. So technically, we could power this up and test it real quick. So, find a cable here that'll work for this. Just gonna plug right in the front side. Plug into our battery we just built. There we go. Oh, still hot. You can see the light. Can you see the light? Yeah, you can see it come on and off. There we go. So it's working. Yeah, so we'll try to clean this one up a little bit, probably. Something like so. Keep everything as neat as possible here. Yeah. So let me find zip ties. Just do another one down here. I do try to be a bit OCD with it. Of course, you don't have to do any of this. You could just leave it the way it is, but All right. So all in all, I think that panel turned out pretty nice. And again, you could have made these wires super short if you wanted to. I just like to have some extra in case you ever have to take this apart. Maybe, you know, one of these things breaks out or whatever. You just cut the cable ties and you have some wire to work with. You're not like yanking on tiny little wires. So I think that'll work out nicely. Maybe I should have left that red a little longer, but it'll be okay. Yeah. So there we go. So now, we'll just need to go out into the garage and cut the hole out, and then we can stick it in there. Because later on, when I get the mount, we'll get that in there. But for the most part, we can see somewhat of it in action today. So let me go cut a hole in a box. I'm not going to show you guys that. It's not all that exciting. I'm just literally going to take a jigsaw and cut out this bottom hole, and then we'll stick it in there. So I'll be right back. Okay, so we got those holes all cut in. I just ground down the top and then filed over it to make sure it was flat. I had a second one of these to use just as a template. Yeah, so nothing too exciting. I went ahead and took out all the front panel pieces of this. Now we should just be able to slide this wiring harness down in there. And what we'll do is we'll use the locking nuts in the back side of this to also hold it. I mean, you technically don't even need these screws, but we're going to put them in anyway. So, one thing I don't like about this design is how close these are together, but I mean, I don't have any space to really work, so it is what it is. And we'll just try to get that in there. Screw our lock nuts back in. Just the other one. Uh-oh. Uh-oh. Well, this is going to get interesting. We're going to have to get a little creative here. Oh boy. This is gonna be a problem. All right. So let's try to. I don't really like that at all. unfortunately, what I think I'm gonna do, I'll take these little nuts out to the garage. I'm gonna take my belt sander and I'm just going to cut those off. Sand them off, because I won't be able to really get this gasket spinning it like that in the right position. And then when you get to the end, it's just going to tighten up. So, option B. It's always the last 10%. Alright, I'll be right back one more time. Okay, we're back. So I just took these little nuts down with no the ribs. So delete. We have success. Don't tighten those down all the way until you get them all in there. Trying to orientate the switch in the correct position so it goes back how we wired it. Because let's see, positive on top, like that. Okay. Now obviously you could pick a different size enclosure, but the idea of this one was to be as small as possible. I already have the medium size and big size of box that Harbor Freight sells of these things, so I wanted a smaller pack for around the house and maybe day trips to stuff or whatever. These are pretty hard to tighten up, so probably won't be able to see a lot of this one. They have like a little edge around them still at the bottom. I'm just going to use those to grab it. Do my best to tighten them up. Alright, so now plug our switch back in. Like that. Now there is one problem. I completely soldered these ends down here too close, but there should have been that way. So we're gonna have to fix that. That'll be fun. So probably just gonna do that off camera, to be honest, and we'll come back at you when I get ready to solder the 10 gauge on here, and we'll go from there. All right, so I got that fixed. It was not a lot of fun. You never want to make those mistakes when everything's installed like that. It's a real pain to get in there and fix it. But that being said, now we just need to make a cable that goes from there. And basically, it's just going to have to be a real short guy. Nothing too crazy long here. I'm thinking maybe this much. Alright. So just like before, we will put on our XT60 first. For some of you guys that work with these a lot probably already know this, but if not, I'll show you a little trick when doing the device side, this side. So a lot of times if you get these too hot, what happens is you'll melt that pin out. So if you just take a battery side and stick it in there first, it keeps the pin nice and straight and locked in. It also helps spread out the heat to the other side of the connector so you don't melt them down. Find it has worked pretty well for me. All right, I'm gonna move you guys here. Seem to have lost my little piece of aluminum that I used to solder on. Yeah, I don't know where that went. Oh, it's right there. Of course. It's never a good project unless you're looking for something straight in front of you. Every time. Go ahead and strip these out real quick. Well, the big thing is just make sure you solder the right side. I've done it before. All right. Trying to do this as best as I can so you guys can see this, but it's just about impossible, I think, without some kind of clamp. I also find it easier to do one side first, get it just kind of tacked on there, and then come back and get it real good. You get something to hold it against that way. Alright. Don't forget your end. So don't ever make the mistake of trying to push those things on there after you're done soldering. Ask me how I know. It's hot. Alright, so it looks like the cable got a little kitty wampus there, so we're going to fix that because that'll drive me crazy. Yeah, that's better. Okay. Now normally I would heat shrink these too, but I don't think I have any of that size left either. I think I've used it. Well, that's probably going to be way too big. I don't think it's going to shrink that much. I don't have any tube left that size, so I'm going to have to get some more, but that's okay. That'll be fine. So I don't know if I'll be able to do this on camera or not, but I will certainly give it a shot. But yeah, normally I put some heat shrink right here, and then I heat shrink it right to those copper bus bars. Looks good. But I said this gets a little tricky too, because if you get this bar too hot and that wire too hot, which it's hard not to because they're so big, you'll end up pulling it off. Yeah, I just have to, maybe you guys can see like this, and I can work around it. So I like to try to get the wire warm, good and warm, and then the bar. Have something ready to hold it down with. There we go. Probably should have did the ground first, so it would have been a little easier. there we go. Plug this back in once again. Here's the fun part. Obviously, this will be wrapped and everything later and mounted, but until I get my BMS, I can't do that. So we're just gonna plug it in, something like that. Gonna guide the cables down. See how this works. It's gonna be tight. There we go. I have power. Everything seems to clear pretty well. All right, well. Shall we see? Does this one show you it's charging when it's not turned on? Of course not. Uh-oh. Oh, that's working. Maybe. Yeah, it's working. I think it's the cable, not. Something's weird. Uh-oh, tubes. I don't know if that... I thought I tested that charger. Oh, okay. It's charging. I don't know if you can see that, but fast charging. So, yeah, it's working. And then if we hit the switch, no more charging. Turn it back on, charging. Oh, what's up with this one port? There it goes. Yeah. So that seems to work. And we can also do like RC charger. Let's not use this one. It's too big to fit on camera, but we can use like this guy. So that's not too close to you guys. Plug this guy in. Plug it in there. That's really close. There you go. So we could now charge another battery with this, or you know, whatever. Make sure the other one works. Yep, that one works fine. So for now, that pretty much wraps it up until we get our balance cable that we still have to put in right here, and we get the BMS. We'll get that mounted down probably in this little cavity here. Then we'll heat shrink the battery and figure out probably a Velcro strap, or maybe I'll 3D print something that just holds it down there, and we'll figure that out. But until next time, thanks for stopping in, guys. If you liked the video, please give me a like. I know this was a long one, and if you like what you see here, give us a subscribe. Thanks for watching. All right, so look what showed up in the mail. Got the BMS, and here's that screen I was talking about. So this will actually show pack voltage, the amp draw. It'll show individual cells. And I want to say this one's programmable. I don't know. We'll have to test that out. Might do a video just on the BMS itself. For now, if you don't know, this is a BMS, battery management system. It essentially monitors each one of the cells and makes sure they're not too different, and it also does balancing to keep them all the same. So they wire up. They have a pack minus, which goes out to your XT60 plug or whatever plug you're using, and the B minus is the battery. So P for pack, the whole thing, B for battery as it goes onto your battery, and that's for your ground lead. What that allows it to do is disconnect the power if there's a problem. So if it sees like an overcharge or a short circuit or a cell going bad, it'll disconnect the load. This also has a temperature sensor, so I think it does low temperature cutoff, so you don't charge them when it's too cold and ruin the battery, and I believe obviously it'll do the other way. If it's too hot, it'll shut down too. So this is the balance lead. And how this works is, we got the colors here. You got a black, and then for a 4S you have 4 other wires. So most negative, next positive, next positive, next positive, next positive, or most positive. That's what I will solder these tabs on here for. So in our case, this cell right here, which is our negatives coming off of, that's going to have to come off, and that is our most negative side of the battery, and the other side of this cell will be our first positive. So just make sure you keep them in order. I also forgot, I want a separate, well, I'm actually going to wait for that. I have to wait till I get some arc connectors, so never mind. But I am going to wire a separate wire on here for another balance lead, so I can look at it myself in that little port at the top of the box. This guy. We could plug the cell monitor in there and also look externally if you wanted to, or you could use the RC charger and you plug the balance lead in to balance the battery. Well, you know what? I have. That's okay. I'll just wait. I think that's supposed to be here in a couple of days. Alright. So, we got our most negative on. We're going to flip the pack around. And making sure we're keeping these straight. So this is cell 1. And cell 2. So our next positive, which is the center one. the other side, cell 3. Which is this guy over here. And our last one will be our most positive cell 4. Alright, so now we need to figure out how we want to mount this. And I think most of my batteries I build, I usually just stick them on like that. So I don't think we're going to do anything different with this one. Little double-sided tape. I also did wipe this down with a bit of alcohol too, just to get any oil off of it before I put this on here. Generally do that when I first get them. So. You guys are all screaming at me, I'm sure. Got it. Alright. So I think I want to actually peel this back so we just on the plastic. Not exactly centered either, because I want to leave some room in the front for the cables to be able to bend. Alright. So this will get battery wrapped too, so this tape really doesn't matter at the end of the day. But okay, so now our battery minus will, I did that wrong. Dang it, probably really stuck too. Yep, really stuck. Oh, we got lucky, okay. Let's make sure we're pointing towards our negative this time. Okay. So what I meant by that. I need this blue wire here to come up and grab that. So let's go ahead and undersolder this. Some more solder on there.
I found a tool for like a skeleton. Sounds like logical. What else we're gonna get?
Sorry, my hand's in the way. Just like that. Like I said, battery minus to your most negative. Alright, so then oh, look at that. It's gonna be like perfect. The process is probably a little long. Or do we want to extend it? I don't have a lot of wire room in this pack. I don't know if I want to extend that guy or not. Yeah, I think I'm going to. Let's just... I always feel like those leads are so short. Alright, lost another GoPro ready. So I wasn't sure what you seen of that last time, but I'm going to extend that, and I was looking for how I'm going to do it. I think I'm just going to use one of these heat shrink butt connectors. Generally I would solder these together, but since I don't have any big heat shrink right now, this will do. claim of 10 gauge. I don't know if I believe it. Well, it's on there now. Alright, I'm done with those. Those are not going to be big enough. Okay, well. Let's see if they work. Let's use one of these. If any of you guys have ever tried to shove together fine strand wire like this, but it's an absolutely pain. hopefully this big shrink that I have will shrink down that small. Looks like we're in luck. Cool. Alright, so once we got all that plugged in, it's not a half bad idea. To grab a voltmeter and just double check. Let me check these and I'll show you guys what I'm talking about. So starting from the ground, should have 13 volts at the end. Yep, 9, 6, and then 3.2 because it's nominal. So let's test again. Cell number 1, 2, 3, 4, or excuse me, 3, and then this is 4. This is full pack. So we know our voltages are good. Goes up by roughly 3.2 volts each time, and only then do you plug this in. Do not plug your BMS in until you know 100% sure that your pack is correct. Alright. I'm actually going to undersolder that wire because I don't like how that's sitting like that. I think I want it to be like that. Alright, here we go. And then we'll have to clean some of these cables up, but like I said, this will all be behind a battery wrap, so it doesn't really matter at the end of the day. It'll all be hidden in the shrink. So stick them under. like that. Alright, and then we'll just tape our sense, probably route our sense wire back here. Tape it in with one of the cells. There we go. Good enough. And this is for our screen, so let's see. I'm gonna see if this works.
I wish you the best of luck.
To be honest, I don't really know how this is supposed to work. I don't think there's a switch or
I've
anything.
seen deliver like 8 or 9, 10 before. I mean, I agree with you. I doubt it.
I don't know if I got a bad screen. Or do I have to unplug? I'm going to unplug the balance cable for a minute. No. Alright, well, I guess I'll mess with this and see if I can figure it out. And if I can figure it out, and hopefully it's not dead, because this shipped from China, I will, I'll let you guys know. Alright, so messed around with this a while, and I got it working in English. So I found out that you have to initiate a charge to activate the BMS, which is unusual, so something new with the new smart Dalys. And then once I had that, I found out it was in Chinese. So I spent all last night looking around trying to figure out how to change this thing. Found out it was a flash file. The one I had didn't work. End up posting on Jehu's Powerwall Facebook, and somebody else had it, and their Daly came with a firmware already. So he sent it to me. I was able to flash it and get it in English, thankfully. Now the next thing to note with this is this screen turns off at a random amount of time when there's no load being drawn or it's not being charged. So when it's idle, it'll eventually turn off. And then if you charge it, the screen will turn back on. And if you pull a load from it, the screen will turn back on. I still have some more playing around with to do on this. This will probably be a video in itself. So for now, I'm just going to unplug it. I got the pack kind of tidied up a little bit. I put my other connector on there so I can balance it. And yeah. So I think all it's really left to do is heat shrink it. I'm going to put some rubber on top of this. Not really necessarily. They also make what they call fish paper that you can do. And that's like a double-sided adhesive, and it's actually made just for batteries. But got one for each side. Will just help keeping the anything poking through the top or something were to get punctured or anything like that from it shorting out. Alright, so I think I got that how I want it. Just gonna kind of hold all my cables together here. Grab the heat gun and we will shrink this down. Alright, so that turned out pretty well. I also went ahead and cut the hole out in the box. I still need to solder on my connector to the end of these balance leads, but I will do that later on. Need to bore you guys with the small stuff. So go ahead and plug our pack back in. Mount our screen. If anybody's wondering, they have these little clips and they grab onto those holes. Let's see. I'll be able to show you that. Okay. And for now, I said eventually this will have a plug on it and I'll be able to plug that in. Just gotta make that up. Plugs in there. And I think for a strap, I'm gonna end up cutting a hole, like a slot in the bottom on each side, and use a big Velcro strap. Generally I would have a piece of wood underneath and then I wouldn't cut a hole in the bottom, but since I literally have like no space between this pack and the top, I don't really have many other options. So I probably will actually go this way. Keep it from sliding back and forth. I mean, it really can't, and then it can't come up either, but not that it really can. So go ahead and make sure our wires don't get stuck. Nope. Sure our wires don't get stuck. Close down. So let's see. How well you guys can see this. Now you can prop it up with something. So let's just do an unbalanced charge real quick. You'll see like the different screen settings. All right. So I set the charger for 20 amps. I'm trying to see if you can see it through the GoPro, but maybe if I turn off this light. Yep, so you can see the charge current is 20 amps. Tells your little battery and all your stats. You can also see individual cells, which is probably one of my favorite parts. And somehow you can change these settings. You can hit the set, but I haven't been able to get mine to stay, so I don't. The last version in Chinese had a password that I entered to change those, and this one doesn't, so I still have to do research on that. But like I said, I'm probably gonna do a whole video on all that stuff, see if I can get all that figured out, and then do a whole other video on this BMS itself for any of you guys looking for that information. But I think that'll wrap this one up, guys. I appreciate you hanging around if you did this long. If you liked what you see, consider subscribing. Thank you.